All right, we're going to be looking at hexadecimal numbers. We're going to look at two items associated with hexadecimal. First is what is hexadecimal, and second is how hexadecimal is used to represent binary numbers. All right, so what is hexadecimal? Well, hexadecimal, oftentimes you will hear it referred to as just hex numbers, is a base 16 number. So from an earlier video, we learned about binary and decimal. We know that has to do with the weights. Well, what I want to look at is beyond just the weight, is what digits are used. So decimal number, or base 10, are the numbers we use in everyday life. There are 10 possible digits. We have 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. So those are all the digits that we use. Usually, let's say we're starting off at the 0 spot. As soon as we get to 9, we want to roll over. We roll all the way back to a 0, and then we will get a 1 on the next available spot. Well, let's look at binary. Binary is base 2. There are only two possible digits, a 0 and a 1. If we're on the 1 spot and we need to add an extra 1, we're going to come back around to a 0. Next spot gets another 1. So what about base 16? Well, base 16, I'm going to have 16 possible digits. But with 16 possible digits, what do we use after we get from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9? Well, we're going to use letters for every new digit. So the new digits we're going to use are A, B, C, D, E, and F. So for hexadecimal, we go from 0 all the way to F. All right, so let's look at the connection of hexadecimal to a decimal number. Well, the digit 0 is 0 in decimal, a 1 is a 1, a 2 is a 2, a 3 is a 3, a 4 is a 4, 5, 5, 6 is 6, 7 is 7, 8 is 8, and 9 is 9. Well, what are this A, B, C, D, E, and F? Well, A will be the value 10, B is 11, C is 12, D is 13, E is 14, and F is 15. So we can say decimal goes from a 0 all the way to a 15. The digits are 0 all the way down to F. All right, we can also make the connection using this idea of hexadecimal to binary. So if we take all of our hexadecimal digits, 0 through 4 in this column, 5 through 9 in the next column, and A through F in the third column, each digit can be represented as a binary number. So if we're going all the way from 0 to 15, we would need exactly 4 bits in binary to achieve that number. So we would get the number 0. How is 0 represented as 4 bits? Well, every single digit is a 0. A 1 would just have a 1 in the 1 spot. A 2, well, we have 2. And then 3, 4, 5, 6, 7, 8, and 9. A gets 10, B gets 11, C is 12, D is 13, E is 14, and F is 15. Now this table here, you will want to have put into your memory, because a lot of what you're going to be doing when I show you the next example is looking at a binary sequence and mapping it into what the value is in hexadecimal. So we're going to need to always know in our mind, an 8 is a 1, 0, 0, 0, and A is a 1, 0, 1, 0. Over time, this will all come into memory, and you'll be able to quickly identify a hexadecimal with its binary representation. So why are we learning about hexadecimal? Well, using hexadecimal is easier to represent a binary number. It can be very difficult sometimes to represent binary number because they take up a large number of digits. And also, if only a 0 and a 1, it's very easy to mix numbers around. For example, take a number 1100, 1101, 0101, and try to repeat this number to a friend. Well, sometimes you might find it's a little bit difficult. It could be difficult because you get a sequence of, what's that, 2 ones in a row or 3 ones, and sometimes you may flip a 0 and a 1. You could lose a digit. So to kind of make it a little bit easier, we're going to use hexadecimal to represent a binary number. Okay, so let's take this number I said to try to repeat to our friend, and let's see if we can make it easier to get that number across. All right, so we have the number 1100, 1101, 0101. Now you can make it a little bit easier to talk to by grouping. So let's group everything in groups of 4, starting at the right-hand side. So I took that and I did that. So we look towards the bottom of the screen, we see the groupings of the 4. Now, it's a little bit easier to read it out in binary to say 1100, 1101, 0101. The groupings are easy number for us to remember, kind of like how a credit card is divided into groups of 4. Now let's make this a little bit easier by having different options than just a 0 and a 1. So what we're going to do is take each group and we're going to say a hexadecimal digit is a 4-bit number. So I'm going to take 0101, and we need to figure out what digit is that in hexadecimal. So let's quickly scroll back. 0101, we see that is hexadecimal number 5. So I'm going to say this grouping here is 0101 is a 5, a 1101 is a D, a 1100 is a C. So we could say this 12-bit binary number can be represented as CD5. Now try taking that number and using hexadecimal, repeat CD5 to a friend. You're going to see it. That's a lot easier. Not going to be any chance of a mistake happening. So this is kind of why we will want to use hexadecimal digits. So here are some digits to try for yourself. So I have 3 examples here. Pause the video and try to work these out yourself. Now you're going to find out on some of these, they're not divisible by 4. You always start at the right-hand side. If you are missing digits, when you get to the leftmost points, add in zeros. All right, so pause the video, and once you're done, come back and see the answers. All right, so here are the answers. Number 1 was 30D. Number 2 was F173. And number 3 was 13. Well, I hope you were able to understand hexadecimal numbers and how they're used to tell binary digits.